Hello and welcome to this lesson where we're going to look at the specific heat capacity required practical, which is part of the energy topic in GCSE physics for both combined science and separate science. In today's lesson we're going to try to calculate the specific heat capacity of a material by using the specific heat capacity equation. So if we are successful and we learn in today's lesson, we should be able to calculate the energy stored in a substance via the specific heat capacity equation, use the specific heat capacity equation in different situations, and carry out an investigation to find these values experimentally, which falls into the following part of the AQA physics, combined science and separate science specification by looking at energy changes in systems. So we're looking at required practical activity 1, an investigation to determine the specific heat capacity of one or more materials. The investigation will involve linking the decrease of one energy store to the increase in temperature and subsequent increase in thermal energy stored. So if we learn in today's lesson, we should be able to work out the specific heat capacity of a material from experimentation and state in particular the specific heat capacity of aluminium. So in this investigation, we're going to need the following apparatus: a metal block, a power pack, wires, a thermometer, an immersion heater, a voltmeter and an ammeter. So we're going to connect a heater to a 12 volt power pack and place it into an aluminium block, connect an ammeter, power pack and heater in series, connect the voltmeter across the power pack, turn on the heater and with a stopwatch measuring the time, allow the heater to warm up in the block for 3 minutes, and in this time record the current and potential difference in the electrical circuit. Then after 3 minutes record the temperature of the block with a thermometer. This will be the starting temperature. Reset the timer and begin the heating process. Then every minute record the temperature of the block and calculate the work done or energy transferred into the block by using the equation energy transferred equals potential difference times by current times by time, and you carry this out until 10 minutes will have elapsed. So to start off the investigation, you would retrieve an aluminium block. All the blocks have their masses stated on them, but they should be 1 kilogram. This is useful because the word specific in physics means per kilogram. You would retrieve an immersion heater and place it into the block. Now the immersion heater provides energy into the block, so it will increase the thermal energy store of the block. Now the whole of the heater should be in the block. If it's not, it's an error in the investigation because we're measuring the energy supplied by all of the heater. You would then need to retrieve a power pack with a number of electrical wires. The power pack should be set to 12 volts, which will be a control variable in this investigation. You will need an ammeter to measure current in the circuit, which would have to be placed in series with the heater and the power pack, and a voltmeter, which measures the potential difference in the circuit, which will be placed in parallel to the heater, because that's the component we want to be measuring the electrical properties of. You'll then need to retrieve a stopwatch, and you'll use the stopwatch to time the investigation. So you'll connect the heater, the voltmeter and ammeter into a circuit with the power pack as shown. Now note the voltmeter is placed in parallel across the heater. The ammeter is placed in series with the circuit, so it's in a loop with the power pack, the heater, get it to make one big full circuit. You'll then turn the power pack on and allow the heater to warm up for 3 minutes. This minimizes the error in the investigation where at the start the heater is not as warm as it will be at the end. So you then start your stopwatch after the heater is heated up for 3 minutes. Now at this point you should record the current and potential difference readings on your ammeter and voltmeter, and you're going to assume that these values do not change throughout the investigation, but obviously this is not going to be the case. There's always going to be variations of fluctuations and will be a source of error in the investigation. Then every minute you'd record the temperature of the block using the thermometer, which is placed in the block. You'll carry this out for 10 minutes. Now remember, when measuring the results, ensure you stand in parallel with the thermometer, because this will reduce the parallax error in the investigation. Now when you record your results, you'll record your results in the following table with time in seconds, energy transferred in joules, and the temperature of the block in degrees Celsius. Now the temperature of the block will be measured by the thermometer in the investigation, so the value should be recorded to the same resolution as the thermometer. Now you can calculate the energy transferred by using the equation energy transferred or work done is equal to current times by potential difference times by time, and you'll round this answer to the nearest whole number when you do this. Now when you're trying to work out energy, you will need to take the readings of current and potential difference in this investigation. So you'd record them at the start of the investigation and assume once again they do not change in the investigation. Now you record the values to the same resolution as the measuring devices, the voltmeter and the ammeter, and you use these values to help you work out the energy transferred into the block. Once you've got these results, you will draw a line graph with the temperature of the block on the y-axis and the work done on the x-axis. Then you would draw a line of best fit in with your experimental results, and the gradient of the line is the specific heat capacity of this particular material. Now to work out the gradient, you draw a right angle triangle with the line of best fit. This makes it as large as possible because it will increase the reliability of the results. You then work out your change in the y value, which is the vertical change. You'll work out the change in the x, which is the horizontal change, and the gradient of the line will be the change in the y value divided by the change in the x value. So, what have we learnt in today's lesson? The greater the mass of an object, the more slowly its temperature is increased when heated, and the rate of temperature changes of a substance when it's heated, dependent upon the energy supplied to it, its mass, and the specific heat capacity, which is the amount of energy to heat of 1 kilogram of material by 1 degree Celsius. And we know that energy in joules is equal to mass in kilograms times by specific heat capacity in joules per kilogram degree Celsius times by the change in temperature. And we can use that equation to work out the specific heat capacity by experimental methods. So if we have been successful, and we've learnt in today's lesson, we can calculate the energy stored in a substance via the specific heat capacity equation. We can use the specific heat capacity equation in different situations, and we can carry out an investigation to find out these values. I hope you've enjoyed this lesson where we've looked at the specific heat capacity required practical, so we can calculate the specific capacity of any material such as aluminium, water or gold via experimental methods. Thank you very much and have a lovely day.